All right, so we're going to go over another example here, and I've got most of it kind of written out already due to the fact that there were some technical difficulties. So I'm just going to kind of reuse it and go over it, and then we'll continue on. What we have here is to find the area of each circle, we want to figure out what scale factors used on the circle and how are the areas compared. And we're going to look at, is it the same as it is with a rectangle? Okay, so with a rectangle, we knew that if we doubled everything, it was 4 times the area. If it's a triangle, so that was with a rectangle. With a circle, we want to show that it's exactly the same thing. So I'm going to call this the actual, this the scale. Okay, and just go from small to big. It doesn't matter. You can do in either order here. But to find our k value, okay, or our scale factor, we do scale dimension divided by actual dimension. So we take the big one and divide it by the small one in this case, because the big one's a scale. And we get that we have a scale factor of 2, meaning that this circle is twice as big as this circle, okay, at least dimension-wise. Okay, so that would be the same for the diameter, radius, circumference, anything that we have to deal with dimensions. When we deal with area, it's a little different though. We know that when we had a rectangle and we doubled all the lengths, the area was 4 times bigger. When we have a circle, the same thing's true. So I found the area of each circle. So this was a small circle, it's 30.68 centimeters squared. And this is the large circle, 122.72 centimeters squared. And if I take the scale circle divided by the actual circle, I get, well, it's because I round a little bit, it's like 3.99 and then a whole bunch more decimals, but it rounds up to 4. Okay, and if I use the actual values, it would be exactly 4. So it's 4 times bigger, which is 2 squared. Okay, so it's 4 times bigger. Now, if we have, so to take a little formula out of there, if you remember the formula from the other lesson there where we dealt with dimensions, it looks exactly the same. Scale area is equal to actual area times scale factor, but now we square the scale factor. So we're just replacing we're replacing dimensions with area, and then we're taking our scale factor and we're squaring it. So that means that whatever this value is, we have to square so we can find what that is. Now, if we mix that up a little bit, and we're going to kind of use that in the examples later on in subsequent videos, if we want to find what k is, we have to do the square root of the scale area over actual area, okay, because it's squared. If we just want to find k, we do square root. If we want to find how many times bigger the area is, that's just k squared. Okay, so k squared is how many times bigger the area is, okay, in comparison. And if we want to find the actual area, we take the scale area and we divide it by k squared. Now that means that we take the value of k and we square it. Okay, so these are 3 little formulas that we can use if whatever we need to find, the area, what k is, or the actual area. And if we just want to find how much bigger the area is, that's just k squared, so then we don't take the square root of that value.